Let's suppose I choose the maximum of the two. So this is bigger. So let's suppose I choose this. But if I choose this, I may pick x here, and look what happens. It does not fall within epsilon from L. That's the reason why we always pick the minimum. So let me repeat once or twice, and then we write it. Okay. Why does the limit exist? Because for absolutely every possible epsilon, as big as small as you want, for every epsilon, I will be able to find the corresponding delta near A. Again, for every epsilon positive around L, I will be able to find the corresponding delta near A, such that whenever I pick x in here with a distance smaller than delta, I pick an x, not here, not here, but with a distance smaller than delta, the f of x, of f of the function of this point, of this x value, will fall within smaller distance than epsilon away from the limit. This happens only because the limit exists. Okay, one more time. For every epsilon positive, as small as big as you wanted it to be, near L, but positive again, I will find the corresponding delta near A, a positive value, of course, delta is positive, such that every time I pick x close to A, not further away from A than delta, not longer distance than delta, either here or here, f of x, f of this x will fall within epsilon away from the limit. So this mechanism repeats itself indefinitely. Delta depends on epsilon. Delta can always be found if the limit exists. Okay, so now let's put this in writing. See how we write this. So here's the definition. The limit, we always start with the limit as x approaches A from either side of f of x is L. This is double equivalency symbol, which means we have to prove this way and we have to prove this way. But I'll make this way very simple. Just one line. We don't have to do anything else. So the limit exists implies, since I don't have enough room here because I made this symbol too big, I'm going to write it here. For every epsilon positive, there exists, I will find a delta positive such that for every epsilon positive, I will find a corresponding delta. Delta depends on epsilon. Delta depends on the epsilon I pick, or the general or generic epsilon. For every epsilon positive, I will find there exists, definitely, guaranteed, a delta positive such that the distance between x and A, every time I pick x close to A, leave a space here because I want to explain that, is less than delta every time I pick x with a shorter distance than L from A, and we cannot pick A. So that is signified by this. And you can say the absolute value needs greater than 0. The absolute value is always positive. What are you doing? Well, the fact that the equal symbol is not there signifies that I cannot pick x to be A, which we already know. X does not equal A. That's all it means. This says pick x, but not A. How do I show that? By not having the equal symbol here. This will imply that the distance between the f of this x minus the limit will definitely be less than epsilon. One more time here. For every epsilon positive, I will find a delta positive such that every time I pick x, but not a, I cannot pick a. Every time I pick x here with the distance between x and a, this is the distance between x and a being smaller than delta, the distance between L and f of x, the distance between f and f of x and L will be less than epsilon. So that's the definition. If you don't like this symbol, you have to write in words. For every epsilon positive. If you don't like this symbol, you would write there exists. I will find a delta positive. If you don't like this symbol, you'll say such that. But the rest you have to write as is. The distance between x and a less than delta. I pick an x. If I pick an x, its f of x will be close to L, epsilon close. Okay, so let me show an example. And you will see, oh, that's it. And yes, that's it. We're only going to look at linear functions. And I'll show you how to show both sides. And that's all I'm going to ask you from this section. Okay, so I'm going to pick, let's say, 20. And this is limit as x approaches 5 from 3/2 x minus 1/2 equals 7. So the problem is asking, so let me show you, I picked it. So this is 2.4. And we can look at numerical examples in a minute. I just want to show you how simple this is. And you can say, you're not responsible for anything quadratic or cubic or absolute value or the square root. No, just as simple as possible, linear. I'm happy. So I picked this. Okay. So first of all, is it true? What if it's wrong? When I start trying to find something that doesn't exist. So how do I know? How do I check whether this is true before I present the epsilon delta? So show using epsilon delta definition. So is this true? How do I verify? Anyone?
Plug 5 in.
Say it again.
Plug in 5.
Of course. So 15/2 minus 1/2, how much?
14/2, which is 7.
That's it. So then, awesome. So then we have the double equivalency. And we have to write the definition either in words or in symbols. It's up to you. For every epsilon positive, I will find a corresponding delta positive such that, oops, what do I write in here? Let's think for a moment. Let's compare with the definition and tell me what you would write here.
Is that 3/2 x minus 1/2?
Very good. X minus 5, of course. A is 5. Excellent. This implies, and let's see what we write here. Anyone?
F of x minus 7.
But I do have a function now. But you're right.
So 3/2 x minus 1/2.
That's it. Awesome. Excellent. That's it. So here's our first step. One direction, we will start here. This is our starting point. And after a sequence of steps, we want to arrive here. So this is the start, arrival. Okay. So this is my starting point. I see the least common denominator is 2. Can anyone tell us what to do next? What is needed here? What do I multiply 7 by? For the least common.
Minus 1 minus 14.
Very good. So 3x minus 1 minus 14. Awesome. Everyone understands that, I think. Yes? Please stop me if you don't. Please. Okay. Good. Next step. I have 3x minus 15. A side note. The absolute value of a times b is the absolute value of a times the absolute value of b. Also, the absolute value of a over b is the absolute value of a over the absolute value of b. So we have to use and show these properties step by step. So, can I factor out anything at the top? 2 key words in math. Factor, simplify. If you don't learn anything from me other than this, I'm happy. But I'm hoping you're going to learn way more. Okay, so what should I do to the numerator?
Factor out 3.
Excellent. What is left in parentheses? Do not touch the absolute value. You saw how difficult the absolute value is. Don't touch it. So what do I have in parentheses?
X minus 5.
Brilliant. Now I have to use these properties. I have to write them as they are. The top is a product, so I have the absolute value of 3 times the absolute value of x minus 5. And the denominator is the absolute value of 2 less than 3. Epsilon, of course. Now, this is a mandatory step. Now I know you'll say, but the absolute value of 3 is 3. I agree. And the absolute value of 2 is 2. I agree. So remember what was our starting point. And look at our arrival. We want the absolute value of x minus 5 alone on one side and everything else to the other. Okay, so what do I have to do to both sides to simply keep just x minus 5 on the left?
Multiply by 2/3.
Excellent. Multiply both sides by 2/3. 2/3 times 3/2 is 1, but I have to multiply on the other side. And now please compare this to this and tell me what delta must be. Always remember, delta depends on epsilon. So please compare this piece to this piece and identify delta for us.
Two-thirds epsilon.
That's it. 2/3 epsilon. That's it. Great job. And now part 2. It's one sentence. Now the other direction. Show that delta equals 2 epsilon over 3 works by reversing the steps from above. And I'm not going to ask you to go backwards. That's good enough for me. But this is what we should normally do. There is no need. So, indeed, we kept our word. For every epsilon, we found a delta which is positive, and that's the delta. And if I tell you, let's take epsilon 0.1, can you give me the corresponding delta?
.2/3.
Yes, 0.2/3. If I say epsilon is 0.5, can you give me the corresponding delta?
1/3.
1/3. And you can go on forever. With any epsilon positive, the formula will give us the corresponding delta. Can I ask you to upload the last page? That's it. That's all I'm asking you to do with 2.